Assalamualaikum warahmatullahi wabarakatuh and good afternoon. So we wait for another 3 minutes. If we'll start our class at 2:10. So just wait for another 3 minutes for me to admit your friend in this Zoom session.
Satu.
All of you could see this slide, relational calculus.
Yes.
I think for today, hold on, I accept your friend first. Okay, for today we're going to cover this topic that is this topic that is relational calculus. Okay, we have covered relational algebra. So for today. So on Thursday, I'm going to discuss the assignment that I have you have submit in Putra Blast, and also your first test. The first test, I guess all of you have your marks, right? You have seen your marks in SMP. So going to discuss on especially on the question number 2. Okay, question number 2. Some of you, well done on attempt the question number 2, but some of you, I think, might be, I don't know, whether misinterpret with the question or the understanding of what we call EERD, okay, ERD, the ERD, okay, based on the description of the of the question. But then, since today we only have one hour class, so I think I finished the relational model on the relational calculus. Okay, relational calculus. So let us look at this topic, the relational calculus. So of course, relational calculus is different from the relational algebra, but okay. A relational calculus, if you could see in this slide, is also expressed and create a new relation, which is specified in terms of variables that range over rows of the stored database relation. So actually, the relational calculus, okay, it will give you a new relation. So that is rows, right, of the stored database relation, which we call as a tuples calculus, or over the column of the stored relation, which we call as a domain calculus. Remember, when we talk about rows, we are talking about the tuples. When we talk about columns, we are talking about the domain. Okay. So in the calculus expression, definitely there is no order of operation to specify how to retrieve the query result. So in the calculus expression, we only specified only what information the result should contain. So that is why highlighted here. We only specify what information in the result should contain. So we're going to look at the example how to write a relational calculus as compared with the relational algebra. So this is the main distinguished features between relational algebra and relational calculus. So for relational algebra, you have the what they call order of the operation. However, in the relational calculus, there is no order of operation. So here, relational calculus is considered to be a non-procedural or declarative language. So in other words, okay, relational algebra is a procedural language. So here, okay, it's a procedural language. So we have is a way of stating a query, meaning that in relational algebra, we must write a sequence of operation to specify a retrieval request. Okay, that is the difference between non-procedural and procedural language. So let us look at the how to write the relational calculus. So the tuple relational calculus is based on specifying a number of tuples variables. So we have to specify a number of tuples variables. So each tuple variable usually ranges over a particular database relation. So meaning that the variable may take as its values any individual tuples from the relation. So here we need to know what is the range of the tuples in the relation. So this is the simple tuple relation calculus query. This is the how you write the relational calculus. So curly bracket, T is tuples, and then bar, and then the condition of the tuples, COND-T. That is the conditional expression involving the T. So T is tuples. So the result of Scher's query is the set of all tuples T that satisfy the condition. Still, it has also a condition, but how to write the condition in the relational calculus, we do not have to specify the state or what they call the sequence of operation. So this is an example how to write the relational calculation. So in this example, to find the first and the last name of all employees whose salaries is above 50K. So for relational calculus, we can write the following tuple calculus expression, because we want to find, right? We want to project first and the last name of the employees. So meaning that the tuples of first and last name of the employee should be retrieved, right? Where the condition is salary is above 50K. So curly bracket, don't forget about the curly bracket, close and open curly bracket. T is the tuples. So this T refer to the tuples of the employees, right? So the condition, this is the condition part. Okay. So what we want to display, what we want to retrieve? First and the last name. So T, so this refer to this T, the tuples, okay? T dot F name, comma, T dot L name, bar, employee T. So employee T is the condition, the relation, right? T, the relation is T, employee T, and T dot salary is greater than or more than 50K. So this is how you write the relational calculus. So the condition employee T specify the range relation of the tuple variable T. The variable T is employee. The relation is employee. So the first and the last name is the projection. Projection by F name, comma, L name of each employee tuples T that satisfy the condition T dot salary more than 500K, where we will write the selection in this form, right? If it is in the relational calculus. Okay, this is the example of it. This is how you write it. Okay, so if it is relational algebra, so result, right? So we'll have F name, T name, L name, right? You will have sigma, sigma salary more than 50K, right? So you have here employee. So this is how you write the relational algebra. So this is how you write in form of relational calculus. Okay, let us move to another slide. Okay, this one is on the condition. Okay, the existential and the universal quantifiers of the calculus, okay, of the relational calculus. So you will have two special symbols called quantifiers. So meaning that we will have two special symbol quantifiers which appear in the formula. So the first one is the universal quantifier. This is we use this symbol to quantify, okay, to denote the universal quantifier, and this symbol to denote the existential quantifiers. So the tuple's variable t is bound if it is quantified, meaning that it appears in an universal quantifier t or existential quantifier t. Otherwise, okay, it is free. So meaning that it will be bound in these two quantifier. So i.e., okay, f is the formula. Then this is how we're going to write the formula using the quantifier, either universal quantifier or existential quantifiers. So this is the statement, okay, of the formula. The formula of the existential quantifier, and also the formula of universal quantifiers. So let us move here the example of it. Okay, we'll look on the example how to use the universal and also existential quantifier. For the universal quantifier, that is for all here, for all quantifier, because every tuples in the universe of tuples must make formula that is f true to make the quantified formula true. So meaning that if you want to have for all, so you need to use this universal quantifier. But if it is only there exists, okay, so we're going to use the existential quantifier, that is this one. So this will use for all, and existential is used for there exists, okay, there exists, meaning that any tuple that exists in the universe of tuples that make f true to make the quantified formula true. So the keyword here is for all and there exists. Okay, let us look at this example query using the existential quantifier. So I'm going to use the the existential quantifier. So we want to retrieve, okay, the name and address of all employees. Okay, right? We want to retrieve the name and address of all employees who work for the research department, right? So meaning that we're going to, right? We are going to join, right? Joint, not just employee, but also in the department. But then they only exist, okay? Here you can see that we only want to retrieve the name and address of all employees who work for the research department. So you know that way to get the research department, definitely in the department relation, right? So the query can be expressed as, okay, t.f name, t.l name, and t.address, okay, bar, this is the condition, employee T and existential D. This D refer to department, right? Refer to department because we only want that exists in the department. So where the condition is department D and D dot name is equal to research and D dot number is equal to T dot T number. So this is how we write the write the the relational calculus for existential quantifier. So the only three tuples variables in a relational calculus expression should be those that appears to the left of the bar. So the three tuples is here. This is the three tuples will be appear. Okay. In this query, right? In this query, t is the only three variables. It is then bound successfully to each of the tuples. So it is bound to the condition, of which is stated in the right after the bar. So if a tuple satisfies the conditions specified in the query, the attribute f name, l name, and address are retrieved for each just tuples. So the condition employee T and department D specify the range relation for T and D. So here the condition D dot D name is equal to research is a selection condition and correspond to a select operation in the relational algebra. Whereas the condition D dot D number equal to T D number is a joint condition. So you can see that here, right, is the condition that is the select operation. You can see that it is a select operation. So this is another example. Okay. For every project located in Stepford, okay, list the project number, the controlling department number, and the department manager last name, address, and birth of date. Okay, so here you could see that in this query, okay, in this we want to retrieve the information. So definitely three relations are retrieved, right? One is the employee, department, and also project, right? Because we could not just use employee and relation of project, because in employee, you do not have any P number, right? The project name in the employee. So, but we have department number in department and also in the project. So here, okay, to write it in the form of relational calculus. So P, because it says here, for every project located, this is the project number, we want the project number, and then the controlling department number, and the department manager last name, address, and birth date, right? So P dot P number, because we are going to use the project P, and M, right? So here, okay, P dot P number, comma, P dot D number, M dot L name, because we use employee M, okay, as the aliases for the employee. So M dot L name, M dot B birth date, M dot address, right? Address bar. So this is the, of course, for the project P and the employee M, and P location is equal to Stafford, and of course we only want that exists department where okay, the P dot D number equal to D dot D number, and D manager underscore SSN is equal to M dot SSN. So this is how you use the existential quantifier of D. Okay, let us look at another example here. Okay. Here we're going to use double, right, existential of the relation. Okay. Here list the name of each employee who works on some project controlled by department number 5. So here, of course, we're going to refer to employee, project, and also okay, project, right? Project. Okay, for project we have P name, P number, P location, and D number. Okay, because here is only one, only what they call list the employee who work some project department number 5, right? Number 5. So employee and existing X is from the project and works on W, and X that is from project where D number is equal to 5, and of course we need to join, okay, from the W.ESSN, that is from the works on, and E.SSN, that is from the employee, and X.P number is equal to W.P number. So X is from the project and W is from the works on. So this example, okay, you refer back to question 5 of the relational algebra. That is page. You refer back to this here, okay? Refer back. I think you have done also, right? The single expression of the relational algebra. This is how it works. How what you call the joining of the table in order to retrieve name of employee who works on all the project controlled by department number 5. So so that is question number 3. Okay, this is another example. Okay, for each employee, retrieve employee first and last name and the first and the last name of his or her immediate supervisor, right? So this is unary retrieval of the information where we're going to refer the same relation. So definitely we're going to use different aliases, right? So here EF name, EL name, and then we also want to know his or her immediate supervisor. So S.F name, S.L name from employee E and employee S, and E.super_SSN is equal to S.SSN. So this is also I think you can also write this in the form of relational algebra for this one. Okay. So this will be project. So this will be the selection. Okay. Okay, is there any question for the relational calculus before we go to SQL? Okay. So can we move to the SQL based on the tuple calculus, meaning that we can write in form of relational algebra, write it in relational calculus, and we could also write it in the form of SQL language. So meaning that language SQL is based on tuple calculus. It uses the basic block structure to express the query in the tuple calculus. But in SQL, you must write in this form. So this is the basic blocks structure of SQL. So you have select. Select is different from the select of relational algebra. When you talk about select in relational algebra, is the condition. But if it is in SQL, this will start with this select. So you need to write list of attributes. In the algebra, we call it as project, right? So here's a list of the attributes from list of relation. Where is the condition? So I guess all of you is very competent in the SQL. That is based on your SSK4401, right? Most of the exercise is based on the SQL, right? So you have, apart from SQL, apart from select, from where there is another we have the advanced, right? Where we have group by, having by. So you have group by, having by, and another one is order by. We have group by, having, and the other one is order by. This is the syntax of the expression of the SQL basic block structure. So here, selection clause mentioned the attribute being projected. As I said just now, it's being projected. From is mentioned the relation needed in the query, and where is the selection as well as the join condition, not just the selection condition, but also the join condition. So another language which is based on tuple calculus is QUEL, QUEL, which actually uses the range variables as in tuple calculus. So its syntax includes range of variable name is what is the relation name. This is just an example, okay, but we're not going to focus in this SQL, okay, cool. So then this use retrieve list of attribute from range variables where condition. It's the same thing, but then the way the syntax is written is different from the SQL statement. So this language was proposed in the relational DBMS, that is Ingress. So, so the DBMS Ingress use the SQL language, and it is no longer there, okay? Meaning that this QEL is no longer being used. So for any DBMS, okay, we use SQL statement to retrieve the information. So that the statement of SQL is based upon the tuple calculus. Okay, it's based on the tuple calculus. That is why we need to understand the relational algebra and also relational calculus. So is there any question? Okay. Okay, if you do not have any question, okay, we'll stop our class here. Okay, don't forget to click your attendance. So next week, not next week. I mean on Thursday, we're going to discuss our assignment and also our test, okay, our test. But okay, I will give you if for the assignment, okay, I will give you what you call some of the assignment if you want to resubmit, okay, the assignment. I will give you time for you to submit the assignment, okay, resubmit the assignment. But for For test, definitely there will no resubmission for the test. Okay, just that I give you I give you what you call opportunity, okay, for you to resubmit the exercise, okay, the assignment. Okay, I will give you another, for those who want to resubmit back, I will what you call, I will look at it back, okay, and we're going to discuss that assignment first, okay. You do it on Thursday before we move to new chapter, okay, before we move to a new chapter. With that, okay, see you on Thursday, okay, and please click your attendance. I think I have already input your attendance in SMP. Except I think I haven't what do you call, I haven't update. I think some of you did send me your letter of why you did not attend that particular time. For that I haven't update in SMP. Please check your attendance in Putra Blast and also SMP, because definitely for final, okay, you need to have 80% of attendance for you to attend the final. Okay.
Okay.
Okay. See you on Thursday.
Thank you, Doctor.
Okay. I end the meeting.
Thank you, Doctor.
Thank you, Doctor.
Thank you, Doctor.
Thank you.